Hi guys. So, not that much time until after party. We almost did it. The first day of amazing conference. Really surprised for everything what's happening. Good winning. And, yeah, let's talk about not the most important thing, but really important thing, money. How to make money with your users and not only. Actually, this talk is not about money. But let me introduce myself a bit more. I'm Denis Radin, and social networks you can find me as a Pixels commander. And once in the year 1991, my father said me, "Hey, Denis, this is your thing, and you new a computer. It's ZX Spectrum, so you can play with it. But there was not that many games. I started to develop with it with the basic, and then there were also some nice games. So the one nice game was Manic Miner, which was awesome. So Manic Miner was a game about a miner who was trying to escape from a dungeon and then, yeah, just to get out and get as more resources as possible. So when I was preparing the talk about mining in browser, I said it should be themed with Manic Miner. So I themed it with Manic Miner. And then my passion for computer games and developing computer games progressed. Then now I work for a company called Evolution Gaming, where we do computer games with WebGL and React Redux, which is a quite interesting combination of mainstream front-end tools and WebGL. It's really hard to find something like that. And, it's a small piece of what we do. Kind of a small demo. So shaders, performance optimization, React Redux, all good things. And also, I'm mastering a workshop, Challenge on Native. So Challenge on Native is a workshop how to develop applications with web technologies and make them as fast as native applications. So I'm really into web performance. And once, a friend of mine, who is like a venture investor, asked me, "Hey, Denis, I know that you are into performance. You're like a performance geek. Can you try and make this research for me? Can we mine with users' browsers? So how fast it's going to be, how much money we can get from there?" And for me it sounded, "Hey, do you want some performance challenge?" I said, "Yes, of course, I want some performance challenge," and I did it. So now I try to share all these insights with you. Basically it's insights on web performance and what we can get using with all these new fancy APIs like WebAssembly, WebGL, GLSL shaders, and so on. Let's start with basics, the theory. How many people knows why do we need mining at all? Okay, it's going to be interesting. What the heck is mining? So the mining. You know blockchain. We are not going to discuss blockchain a lot. Do we need it or not? And why humanity really needs a blockchain, or maybe it sucks. But then, okay, blockchain, it consists of blocks. It's a chain of blocks of data. For a Bitcoin blockchain, it's blocks of consist of who is sending money, who is addressed, and then amount of money sent. So then, except data, we have some like system information, hash, and what's interesting for us is a hash and hash of previous block. The hash is a fingerprint of a block. So what's the data inside of a block, including all service fields? It's getting like a fingerprint. Once any field there is changed, the hash is changed. You know how hashing works probably. Yes. And then we have this hash of previous block, which creates a chain, like connecting one block to another, and then we have a chain, and chain lives in a distributed way. Like everyone can add a block to a chain. Well, in theory, then it's okay when we have only one guy adding a block, but then there are a lot of nodes trying to insert their blocks into chain. And then we can run into a problem of concurrent adding, and but blockchain requires to keep a pace of adding blocks, like a strict, every 15 minutes it should, for Bitcoin, it should add a new block to keep everything going. Then, blockchain can get out of control if many people try to add blocks. So, what was invented? The kind of algorithms called proof of work. Proof of work means that you should perform some kind of, solve some math problem, for example, and then it grants you, so you're trying to solve it, you spend some efforts like computer resources, and then it grants you a priority to add a block to a chain. Yeah, so math problem, when it's solved, you can add a block with this solution. And for this, for keeping chain going, cryptocurrency rewards us with some coins. Ba-dum. Okay, so now we know why do we need mining at all and why we are getting money from there. Because it's one of tools and one of essentials how blockchain works, and we need just to do it. From first glance, it doesn't make that much sense, but actually it does. So mining Bitcoin. To mine Bitcoin, the cornerstone thing is a hash. Like we've been talking about hash, then let's recall it again. So hash is a fingerprint of a block, which is important. For Bitcoin, the valid block have 18 zeros in the beginning. That's a really unique block to have with this kind of hash. And for hashing, it uses SHA-256 algorithm, which is not that simple, but it's well explained, and you can implement in many languages. Basically, I used implementations already existing there for all my experiments, GLSL, JavaScript, and so on. Then the tool, what you can use to get the valid hash is nonce. So you have your data from to amount, you have your hash of previous block, and then you have a nonce. Like what you do, you put some number into nonce, like you put 1, and then you make a hash of the block with a nonce equal to 1, and then if it have 18 zeros in the beginning, the block is valid, you solve the task, you got Bitcoins. Oh, here goes your reward. And then if it's not correct, if there are no 18 zeros in the beginning, then you try nonce number 2, 3, 4, 6, 7, so on. Then the chance to get valid nonce is like 10 in power of 20, which is really a lot of work so far. So it might be really hard to perform on a single PC, doesn't matter how powerful is it, so miners unite into pools. And pools doesn't mean the pools with water, but pools means a server which says, okay, there are 4 people currently mining and connected to me, and then you please do a nonce from 0 to 100, you from 101 to 200, and then so on, so on, so on. So basically distribute the work across people, across miners connected to a pool. So the question is, what will happen if we as web developers got our users of our web application, a website, mine for us and connect them to a pool, and then we'll mine together, and maybe they a bit, and we for sure got a reward for it, and how fast it can be. Okay, then it's a time for Manic Miner. So, what Manic Miner is? It's actually an application which have. Okay, let me tell you what is there. There is a nice logotype of a game from the Spectrum, and then there is a drop-down with you can select a type of miner which we use for experiment. Then there is a field which says how much hashes per second we get, and then there is an algorithm which calculates how much money we can get from there with this number hashes of second. The algorithm is it's basic, but it's based on real data, on real difficulty got from a current Bitcoin website, and then on the price of Bitcoin, which is currently, oh, this one is it's not that precise. I took 900 USD. Do you know how much is Bitcoin now? 7. Okay, let's change it to 7. I trust you guys. Right. Then let's try a first miner, which is a basic one with doing everything in JavaScript. Okay, we have some number from there. The 43,000 hashes per second. Is it a lot? Yeah, in the bottom we have this euro per month label. And then here we have an input, which allows us to tune how many users are mining. So how many users have your applications currently running. So they do their job, like some business tasks, but then in the background, it mines. OK, let's proceed. 100 users mining, 1,000, 10,000, 100,000, 1 million. So if you have 1 million users with this kind of laptops as I have, then mining with JavaScript, just with one thread, will give you nothing a month. OK. So then the idea was, is my hash implementation slow? Oh, basically it was not. Like it's not. It doesn't happen that you're always lucky, but in this case I've been lucky. So from the start, I got the quickest implementation of SHA 256, which is a forge, and then OK. Oh, the implementation of hashing is good. So what's next? The next try was, OK, let's try to mine in parallel. So let's try to mine in web workers, because we have few cores on CPU, and then, yeah, parallel calculations are normally interesting stuff. So I proceeded with doing everything in the web workers. Oh, by the way, when I started to make it, I found a really nice thing called Navigator, Hard Work, and Currency, which says about how many cores are currently available for running web workers. I was not aware of that. Oh, maybe you as well. I will zoom in. It's Navigator, Hard Work, and Currency. Yeah, it's interesting. Right. So it's time for Manic Miner. Web worker miner, and we start. So we see, actually, the number of hashes we get, it's way better, like almost 20. It's 5 times improvement. Not bad, 5 times improvement. Then let's see how much money we will get from there. 1,000, 10,000, 100,000. Oh, right, not 1 million anymore for nothing. And then, OK, it's basically still not enough at all. Then, what about WebAssembly? Because WebAssembly promised us nearly native performance. And then maybe it like saves us and get us out of this JavaScript course, because like we see that JavaScript is not quick enough for mining. Right. So I took a WASM implementation of SHA 256 and applied it to my thing. Now it's time for Manic Miner. WebAssembly Miner. Any bets? How quicker is it going to be compared to JavaScript? Faster. All right, it's actually faster. Yeah, if you do a lot of work inside of WebAssembly, but then you return the result once 10,000 hashes, for example, it's almost 3 times faster, 2 times faster. So it's quite OK, but then, I mean, it's still nothing. It's worse than web workers thing, and then I still can run WebAssembly in web workers. I even didn't try, because I think that if with 1 million I got 0.000 something, if I run it in web workers and it improves 4 times, still will be not enough. All right, then I heard that mining on GPU is fast. And it happens for the reason that if you mine with CPU, you have only 1 core. OK, you can have 4 or 6 if you mine in web workers. But then with GPU, you can run in many, many threads, like GTX 960, which is a GeForce card from NVIDIA, it can run 1,600 computations in parallel, and they're very quick. It's well designed for this kind of mess, right? And in WebGL, we can mine with pixel shaders. Oh, it's really the most exciting part of this talk for me personally. And it's really interesting how it works. So let's imagine there is a canvas, and a canvas of 4 by 7 pixels. Every thread of calculation is a pixel. You can write a pixel shader, you develop a pixel shader which calculates, which executes for every pixel of your canvas surface. So, for example, we said that the beginning of our calculation is going to be the nonce of 4, 3, 5. And then the next pixel decides, OK, I'm pixel number 2 in a row, and then I will take 436, and then so on, so on, so on. So basically, it's being executed in parallel for the whole canvas on a GPU. In many, many threads. So this is a simplification, but you can run in way more threads than that. And then if some pixel was correct, we should return it. So our pixel shader for not valid nonces, it returns black, and then for valid nonces, it returns, for example, white. Then if pixel is white, we know, OK, that's a 7 pixel, then it's going to be 442, for example. Right. And that's the time for Manic Miner. OK. So bets? How much is going to be faster or slower than a normal JavaScript implementation? 10 times? 100 times. OK, let's try. Oops. It's actually a bit faster than a regular JavaScript, but it's not that fast as I would expect. And first, I got really disappointed with that. But then I found the reason why it happens. And it happens for a very simple reason. That I should refresh. Because, I will not going to try to show how much money is that, because it's still the same nothing of nothing. It happens for the reason that you have this calculation. On a huge canvas, for example, you have this 1,000 by 1,000 canvas, and then what you should do to read results, so calculation is fast, but reading results from this canvas is a bit like of JavaScript work. So you get pixel data, and then you should iterate through all this canvas, all these pixels, and see is any of them white. So you do actually for every this piece of calculation, you do a lot of JavaScript work. For every pixel, you do calculation for a nonce, for hashing, and then you do still a lot of JavaScript jobs there. But how it can be changed, like for example, let's imagine that instead of 1 calculation per pixel, we do 1,000. So for a first pixel we do from 435 thousandths, 1,000, and then second also do 1,000 and 1,000. So every pixel calculates 1,000 of hashes, and then we need to read it only once in JavaScript. And then instead of white color, we will put just, because color is basically a number, right? And we can just return a nonce from there. We just put a number, which as a color, we return a number, because the color is the only way you can read from canvas, from the GPU. You can convert it to a buffer, and then read the pixel color. So we start putting just a nonce there, the nonce which is correct. So basically, we reduce this JavaScript performance leak, which was there, because JavaScript is still not that fast as GPU Commons. Then we reduce it by 1,024 times, just by putting to every of pixels instruction, please, in this pixel check 1,024 hashes. OK, that's time for Manic Miner. And here we have a WebGL miner with 1,024 pixels hashes per pixel. And here we have really interesting result because it's basically 200 times improvement. Now we have almost 9 million, 9 million hashes per second. And then let's see how much money is there. Okay, you are happy to earn nothing if you have. Okay, it's way better, but then still, where is my gift for that? What the hell? Like, I got really disappointed because there is 200 times improvement and then still no money. Okay, let me disable the miner because ecology. Yeah, let's see what happened. Let's go backwards in the time and see the evolution of mining tooling. So first there was a fish, but no, actually there was first the CPU era. And in CPU era, everybody mined as we did it in the first miner, in a JavaScript, in a one thread. You can use a few cores and then you have few threads, but still it's not that efficient as a CPU, as a GPU, because as we discussed before, a GPU can be as fast, at least it can run 1,600 threads, and then every thread is also a bit more powerful, a bit more performant than a CPU thread. Okay, yes, GPU era, more threads, more fun. And then some clever people invented ASICs, which are circuit boards, which are very basic, but they're designed specially to mine bitcoins. Oh, many people know it. And then ASICs are as fast as 20,000 GPUs, which actually means that it's some board for mining bitcoin. People use it, and now only this thing can mine. Yeah, 20,000 GPUs. It's basically broken. So you can't mine on a PC anymore. There is this specialized equipment for that. And then I was disappointed and started to look for alternatives. Of course, first alternative was Ethereum. Let's try to mine Ethereum because Ethereum is a second-generation cryptocurrency. It's ASIC proof. Basically, it has algorithm which is not able to reproduce with this special circuit boards, or it's going to be as expensive as a PC, more complicated. So I tried to do that, and then it happens that you need 3 GB of memory to implement Ethereum algorithm, which is really, really a lot. And web is failing there. Actually, not JavaScript, not WebGL can normally get 3 gigs of memory. So it's ASIC proof, and it's also JavaScript proof. Alternatives. Oh, this is a point where I got really disappointed and said, okay, we probably should drop it. But then actually there are alternatives, which is an algorithm which can run under adaptations of web and normally run on a CPU with WebAssembly or ASM.js. And this is XMR Monero. This is a cryptocurrency which is trading now at around 2,000 euros per unit, and then it's really designed to be mined on a CPU. And there are a lot of benefits and a lot of pros behind this currency. It's actually very secure in terms of de-anonymization. So currently, FBI runs research how they already can de-anonymize Bitcoin and Ethereum, but for Monero, they're still not there. And then they invested like $2 million to find a way to de-anonymize Monero. So it's quite a thing. It's not the worst currency you can get. Oh, XMR Monero. Time for many miner. Okay. Any bets how much money we will get from there? 0? Half a euro. Okay, let's try. So the number of hashes is lower because that's a different algorithm completely. We shouldn't look at there. But then look at the number of money we get from a single user. it's something. Actually, for a month, if I just going to keep this open for a month, I will be able to buy a hot dog. And then if there are 100 people on your website, or 1,000 people on your website, with this kind of laptops, you can buy a lot of hot dogs and maybe even leave your office job or your freelance job, and then you have it's quite money, to be honest. I mean, it's possible to get something from there. And yeah, okay, let's stop watching at this. I see it's promising and really I want this, but I don't have this kind of website. Yeah, and even better, like if you want to run XML Monero miner, like a year ago you should just implement everything from the scratch, but now there are clever people who deliver this as a service. So the first one is a CoinHive, which is a really great thing. CoinHive, and that's a service which allows you to run mining on your website in a way like, let me show you. Yeah, that's basically how you run a miner for your visitor. It's very simple. You just put a side key, and then your miner starts. You can set a number of threads, and then a number and a percentage of a time which laptop is going to mine. Like, okay, I'm going to mine only 30% of the CPU time, which is good for user because then UI doesn't stack at all. What also show you about CoinHive? It's actually having a really nice dashboard. So during the conferences when I was demoing that, I mined already some Moneros. I'm not sure how much is that, but it's still a number. I'm running it just for a few minutes. And it's not only thing you can use. There are some more, which is a CoinImp. CoinImp is interesting because what they promise, CoinImp. Because their promise is 0 commission. I'm not sure how these guys are going to survive, but then they promise 0 commission. And it actually works. I know some people mine with it. So CoinImp is the second. And the third one is a CryptoNoter, which is an open source implementation of a pool with Monero, and then you can run your own. It's yeah, it have a JavaScript miner and a Node.js server. So yeah, have a look at it if you want something on your side running on your server. Yes, so we basically try to mine Bitcoin. Tried but failed completely with mining Ethereum, and then we found that there are some cryptocurrencies which fit better for mining them in browsers of your users, and it actually works. But then it opens a lot of questions, like why should we do that? And now I found that, oh, this slide I added today. Like I've been making this talk a few times before, but this slide is only today here because tomorrow is going to be a GDPR. Many people know it because it adds a lot of work to your stuff to do. But then GDPR will make ads, like traditional ads, way less efficient. If you think about that, if these companies can't make this machine learning, which all ads, Google ads, Facebook ads are based on, they're not that efficient anymore. And maybe the monetization with this kind of tooling just going to be more efficient. You can get, as a website holder, you can get more money from there. There's a pros. But then there is also a big question of ethics. Like, okay, I'm entering a website, and this website starting silently. I just see that my cooler is starting. Okay, somebody is trying to mine with my laptop. That's the first thing, and then the second thing, what if this is a mobile device? It's not the problem of just ethics, it's more a problem of battery survival. So, about ethics. First, it seems to be mandatory to have dialogue, there is still no law on that, but from the ethics perspective, it seems to be mandatory that we should put a dialogue. Hey, we are going to mine with your laptop for a bit, and this keeps our website going. We got some money from there, we pay our bills, so please keep it running. And it would be quite ethical. I would say, why not? If you love a website, why not to contribute to sales success in this way? And maybe if Wikipedia start mining with users' laptops for a bit sometime, but they have a lot of users, I can imagine they can stop doing this contribute to Wikipedia please kind of things. And you will just contribute by reading Wikipedia daily. Yeah. Is it worth the money? Well, I think with the right application, it worth the money. And there are already cases for some websites. So I was already talking yesterday about a website. Maybe you know it. It's creativeapplications.net, which is all about interactive design and digital aesthetics. So if your website is focused on aesthetics, you can't show these banners and ads because they make it, the whole aesthetics is broken then. And what you can do, you can put a miner there, which breaks zero visually, but still makes you quite decent money. And they do it. And they show a dialogue. Hey, visitor, we love you, but if you love us, please mine for some time. We are going to make it. It works. It depends. I think they put the preferences a bit too high. Sometimes UI lags. But in my experiments, it really depends on how many threads you run and how much of CPU time you devote to mining, because you can set this in the preferences of CoinHive, for example. So. Yeah, it might affect UI performance, but if you set right options, right settings, it would not. So that's essentially it.